High on a remote Tibetan plateau, 15,000 feet above sea level, robots, not humans, are building a dam taller than a 60-story skyscraper. Controlled entirely by AI, these machines are printing concrete layer by layer to create the world's largest 3D printed structure. This is China's Yangqu Hydropower Plant, and it could change construction forever. But how are they doing it? Instead of using traditional construction methods, they're essentially printing the entire structure like you'd print a plastic toy at home. The Yangqu Dam isn't being built in some controlled factory environment. It's being constructed on the Tibetan Plateau, one of the most hostile construction environments on Earth. We're talking about temperatures that swing from scorching hot during the day to freezing at night. Oxygen levels so low that human workers would struggle to function, and weather conditions that would shut down any normal construction project for months. Yet somehow, Chinese engineers have figured out how to make robots do what thousands of human workers couldn't accomplish safely or efficiently in this environment. When completed, this dam will have a capacity of 1,200 megawatts and produce about 4.7 to 5 billion kilowatt hours per year, enough electricity to power roughly 5 to 10 million average urban Chinese homes, serving about 20 to 40 million people. To put that in perspective, that's more than the entire population of a country like Belgium. And the entire structure is being built using what scientists call additive manufacturing. Basically, industrial-scale 3D printing using concrete instead of plastic. But here's the question that should make you pause. If China can build a massive hydroelectric dam using only AI and robots, what does this mean for the 75 million construction workers around the world? And more importantly, what kind of megaprojects become possible when you remove human limitations from the equation? The technology behind the Yangqu Dam reads like something from a futuristic movie, but it's happening right now. Let me break down how you actually print a dam using artificial intelligence. First, imagine the world's most sophisticated 3D printer, except instead of printing small plastic objects, it's designed to work with concrete and operates on a scale the size of multiple football fields. The system uses what engineers call contour crafting, basically robotic arms that can extrude concrete in precise patterns, building up the dam's structure layer by layer. But here's where the AI component becomes crucial. Traditional construction requires human decision-making at every step. Should we pour concrete today, or will the weather interfere? How do we adjust the mixture for high-altitude conditions? Where exactly should each structural element be placed for maximum stability? The AI system controlling the Yangqu Dam makes thousands of these decisions every hour. It constantly monitors weather conditions, concrete temperature, structural integrity, and even predicts potential problems before they occur. Think of it as having a master engineer with perfect memory and infinite patience overseeing every single aspect of construction simultaneously. The robots themselves are marvels of engineering. Each machine can operate continuously for weeks without rest, working through Tibet's brutal weather conditions that would force human crews to stop work for safety reasons. They're equipped with sensors that provide real-time feedback to the central AI system, creating a construction process that's more precise than anything human hands could achieve. What makes this even more remarkable is the speed. Traditional dam construction takes years of careful planning, with teams of workers slowly building each section by hand. The Yangqu project is being completed in a fraction of that time because the AI system can optimize every aspect of the process simultaneously. The concrete mixture itself has been specially engineered for 3D printing at high altitude. It needs to be fluid enough to flow through the printing nozzles, but solid enough to support its own weight as it builds upward. Chinese scientists spent years developing this formula, testing it in conditions that simulate Tibet's extreme environment. You might wonder, why build this revolutionary dam in one of the most challenging locations on Earth? The answer reveals China's long-term strategy that goes far beyond just generating electricity. Tibet sits on what geologists call the roof of the world. The Tibetan Plateau contains the headwaters of some of Asia's most important rivers, waterways that provide fresh water to nearly 2 billion people across China, India, Pakistan, and Southeast Asia. Control over these water sources represents incredible strategic power. But here's the problem. Traditional construction methods couldn't solve. Building anything substantial in Tibet is extraordinarily difficult. The altitude makes human workers less efficient and more prone to altitude sickness. Weather conditions can shut down construction for months at a time. Transportation of materials and workers requires massive logistical efforts that make projects incredibly expensive. By using AI-controlled construction with minimal human presence on site, China has essentially solved the Tibet problem. They can build critical infrastructure in remote, high-altitude locations without the massive logistical challenges of maintaining large construction crews in hostile environments. This opens up possibilities for development across the entire Tibetan Plateau that were previously impossible. The Yangqu project specifically is being built on the Upper Yellow River in Qinghai province. But here's what makes this strategically brilliant. China is developing this robotic construction technology that can be applied anywhere. While the Yangqu Dam demonstrates the capability on the Yellow River, this same approach could soon be used on sites along the Yangqu and other strategic border rivers that flow into neighboring countries. This creates what water experts call potential hydrohegemony, the ability to influence neighboring countries through water resource control, enabled by construction technology that can build critical infrastructure in previously impossible locations. Think about the implications. If you can build dams, roads, military installations, or mining facilities in previously inaccessible locations using only robots, you've essentially removed geographic limitations from your strategic planning. Areas that were once too remote or too dangerous for development suddenly become viable targets for infrastructure projects. China isn't just building a dam in Tibet, they're demonstrating that no location on Earth is too challenging for their construction capabilities. That message is being received loud and clear by countries across Asia who depend on rivers that originate in Chinese-controlled territory. What's happening at Yangqu represents something much bigger than one dam project. China is pioneering what construction experts call lights-out construction, building megaprojects with minimal human involvement. Traditional megaproject construction is plagued with problems. Cost overruns are normal, with most major projects ending up 20 to 50% over budget. Timeline delays stretch projects for years beyond their planned completion dates. Worker safety remains a constant concern, especially in dangerous environments or politically unstable regions. AI-directed robotic construction solves most of these problems simultaneously. Robots don't get tired, don't make mistakes due to fatigue, and don't require safety brakes or protective equipment. They can work 24 hours a day, 365 days a year, in conditions that would be impossible for human workers, with only minimal human oversight for logistics and maintenance. The cost implications are staggering. While the initial investment in robotic construction systems is enormous, the operational costs are dramatically lower than traditional methods. No salaries, no benefits, no accommodations for workers, no safety equipment, and no work stoppages due to weather or labor disputes. But here's where it gets really interesting from a geopolitical perspective. Countries with advanced robotic construction capabilities can build infrastructure anywhere in the world without worrying about local labor availability, political stability, or working conditions. They can construct ports in hostile environments, build roads through war zones, or develop mining facilities in remote locations where human workers would be impractical. China is already applying lessons learned from Yangqu to other megaprojects. They're using similar AI-controlled systems to build high-speed rail lines through mountainous terrain, construct artificial islands in the South China Sea, and develop infrastructure projects across Africa and Asia through their Belt and Road Initiative. The competitive advantage this creates is enormous. While other countries still rely on traditional construction methods with all their limitations and costs, China can build faster, cheaper, and in locations their competitors can't match. Construction companies worldwide are scrambling to catch up. American and European firms are investing billions in robotic construction technology, but they're years behind China's current capabilities. The Yangqu Dam represents a proof of concept that China's approach works at mega-project scale. The success of the Yangqu Dam project sends shockwaves through multiple industries and completely reshapes how we think about mega-project development globally. For developing countries, this technology represents both an opportunity and a threat. On one hand, AI-controlled construction could finally make infrastructure development affordable in regions that desperately need it. Roads, bridges, power plants, and water treatment facilities could be built rapidly without requiring large numbers of skilled construction workers. But there's a darker side to consider. If AI construction becomes the standard for megaprojects, it concentrates enormous power in the hands of countries that control the technology. Nations that can't develop their own robotic construction capabilities become dependent on technology suppliers for their infrastructure needs. China's dominance in this field means they could potentially build, or refuse to build, critical infrastructure for countries around the world. That represents a new form of technological dependency that goes far beyond traditional economic relationships. The employment implications are equally significant. Construction is one of the world's largest employers, providing jobs for hundreds of millions of people globally. If robotic construction becomes widespread, entire categories of construction jobs could disappear within decades. However, new types of employment will likely emerge. Someone needs to design, program, maintain, and operate these robotic construction systems. The question is whether displaced construction workers can be retrained for these high-tech positions, or whether we're creating a future where construction becomes a highly specialized field requiring advanced technical education. From a military perspective, the ability to rapidly construct infrastructure in hostile or remote locations changes the strategic calculation for conflicts and territorial disputes. Countries with advanced construction robots can build military installations, supply depots, or defensive structures much more quickly than opponents using traditional methods. The Yangqu Dam is just the beginning. Chinese engineers are already working on their next impossible project, a fully robotic city in the Gobi Desert, where AI systems will construct everything from skyscrapers to subway systems without human workers setting foot on the construction site. But here's the question that should keep you awake at night. If China can build dams in Tibet and cities in deserts using only robots, what happens when they turn this technology toward military applications? And more importantly, what megaproject is your country planning that might require technology you don't control? China's new train hits 620 miles per hour, faster than most commercial planes. The technology behind this is insane, and it's going to change everything about how we travel. Click to see how they did it.